continuing our summary of factoring. We have 3 problems remaining. We'll start with number 10, 10y squared minus 7yz minus 6z squared. We try to find a greatest common factor, 10, 7, 6. They have nothing in common. I see that I have y squared and y in the first and the second terms, and then z and z squared in the second and third terms, but there's nothing that all 3 terms have, so I have no greatest common factor to factor out. The second step says count the number of terms. 1, 2, 3 terms. Remember, terms are separated by addition and subtraction. 3 terms, so I'm going to try factoring by the AC method. A is 10, B is -7, C is -6. I'm going to write these as far as descending powers of y go. So as it's written here, even though I've got this z and z squared, I'm going to look at what A, B, and C are based on the variable y. So A is going to be the number multiplied by y squared. B is the number multiplied by y, -7. C is the number multiplied by no y's, -6. It is possible to rearrange the order and have the z squared come first, and then the z, and then the y squared. And you can do the AC method based on the z variable instead. You'll end up with the same factors, but we're going to leave it as is because it's convenient. It's already written in order, descending powers of y. And so here we go. A times C is -60, 10 times -6, and B is -7. I need 2 numbers that multiply to be -60 and add to be -7. I like starting with 1 and working my way up, so that's what I'm going to do. If you spot it right away, you absolutely can just write it down. Or if you think you can find it pretty quickly, you can guess and check. You don't have to do it in order. I like to do it in order to make sure that I don't miss anything. So I'm going to try 1 and -60, add them together, and get -59, 2 and -30, 3 and -20, 4 and -15, 5 and -12, and -12 plus 5 adds to be -7, so there's my factor pair, 5 and -12. I'm going to take that pair up here with the -7yz, and I'm going to write it as 5yz minus 12yz. Whatever variables are in that middle term, I use those exact same variables when I break the middle term apart. And then we'll copy the other pieces down, minus 6z squared, 10y squared in front. And we factor by grouping. Group the first 2 terms, group the last 2 terms. What do the first 2 terms have in common? I see that the first 2 terms, 10 and 5, they have a 5 in common. Y squared, yz, they have a y in common. 5 times 2 will give me 10. Y times y will give me y squared. Plus sign comes down. 5 I already have. Y I already have. I'm missing a z to get back the 5yz when I multiply. Negative sign comes down. And so here 12yz and 6z squared. 12 and 6, I'll have a 6 come out. And then both of these terms have z's, so we'll factor out a 6z. 6 times 2 will give me 12, and I need a y because I'm missing a y. And then I already pulled out a negative, so I need this second one to be positive. 6z, but I need 6z squared here, so I need to multiply by z. 6z times z will give me 6z squared. Negative times positive will give me negative. And now 2y plus z, 2y plus z, they are the same. 2y plus z. And then in the rest of the parentheses are the leftover bits, 5y minus 6z. because when we factor out 2y plus z, we're pulling it out of being multiplied by 5y and 6z, so we want to make sure we group those together in our parentheses. And this is all coming from distributing. Remember, we're doing the distributive property in reverse. So we would take 2y plus z times 5y, 2y plus z times negative 6z, and we would end up with the step right above us if we were multiplying this out. And that's how it works. So we factor 10y squared minus 7yz minus 6z squared into 2y plus z times 5y minus 6z. We do a quick check, make sure that there's no other common factors showing up in the parentheses, and they're all relatively prime. And check for any special products. We have none. Now let's take a look at number 11, 27z to the third plus 64. 27 and 64 don't have any common factors, but I notice I have a z to the third, and 27 is 3 to the third. 64 is 4 to the third. So I have cubes. This is a special product, a sum of cubes. So even though I don't have a greatest common factor, we can use the sum of cubes formula to factor. So the first step is to determine what is being cubed in each one of these terms. 64 is 4 cubed, 27 is 3 cubed, and then z cubed is z cubed. The next step is to then write the skeleton. So sum of cubes has a binomial that matches the sign of the problem, and then a trinomial where the next term is all opposite and the last one is always positive. So we remember this with SOAP. Same, opposite, always positive in the sign. And then in the parentheses, A and B, A, B, A squared, B squared, AB. So this is the pattern that happens with the sum of cubes. So A, 3z, A squared, 3z times 3z is 9z squared. B is 4. B squared, 4 times 4 is 16. And then A times B, 4 times 3z will give me 12z. And there's my factored form for a sum of cubes. 27z to the third plus 64 will factor into 3z plus 4 times 9z squared minus 12z plus 16. Even though this last factor is a trinomial, if I try to factor it using the AC method, 9 times 16 and negative 12, 144 here. I need two numbers that multiply to be 144 and add to be negative 12. Most of the time this trinomial is not factorable, but we're going to check it just to make sure. So we can start out with negative 1, negative 2, 3, and remember we're adding in that second column. So multiplying in the first column, adding in the second column. 4, 5 doesn't work, 6 does. 7 doesn't work, but 8 does. Negative 8, negative 18. Negative 9 and negative 16. 10 doesn't work, 11 doesn't work, 12 is the last one. And we end with negative 24, but notice we need negative 12. There are not two factors of 144 that will add to give us negative 12. And so that second factor in our sum of cubes here is prime. So we cannot factor it further. Now let's try our last one. 3x to the fourth minus 48x squared. I see I have x's, so x squared is a common factor, and 48 is divisible by 3. We can check that on our calculator really fast. 48 divided by 3 is 16. So I'm going to write that down before I forget it. 3 times 16 is 48. And then 3x squared times x squared will give me x to the 4th. And I have common factor of 3x squared that I'm going to pull out. 3x squared. Reverse distributive property, leftover pieces go inside the parentheses, x squared minus 16. Greatest common factor has been factored out. Now we check the factors, count the terms. We have 2 terms. This is a difference of squares. X squared minus 16. 16 is 4 squared. So my pattern, first thing being squared, second thing being squared, 1 plus 1 minus, and we have completely factored that polynomial as well. Working through that factoring strategy, just to recap, we're going to start out and factor out the greatest common factor if possible. We always look for the GCF first. Once we find a GCF or we recognize there is not one, we count the number of terms in the polynomial. If we factored out a greatest common factor, we're talking about the remaining polynomial that's inside the parentheses. 4 terms, we try factoring by grouping. 3 terms, we're going to factor using the AC method. And 2 terms, we see if it's one of the special products that we talked about. Remember that if I have a sum of squares, it is not factorable. And then always step 3, check again. Make sure that you cannot factor anything else. Our goal for these polynomials is to factor completely. We need this skill when we move into rational expressions in the next chapter so that we can work on simplifying rational expressions, adding, subtracting, multiplying, and dividing rational expressions. And so we'll continue to practice factoring these polynomials here. The last lesson in our chapter on factoring polynomials will center around solving equations. So we have one more new thing to learn, but again, notice that we're adding to the previous lesson. Every lesson that we do here in this chapter, we're just adding on one more piece. Here we've summarized all of our pieces, and now we're going to add one more piece to work on solving equations using factoring techniques.